Just a reminder,
So here,
anyone that's interested in taking the ACT test prep, you need to have that information into Mrs. Hillman's today. ACT test prep information due today. Bailey McGuffey, please report to the office.
so here we have 8 to the negative x equals 1.2. There's no logarithm.
Just a reminder that the pop choir is going to meet at 7:35 tomorrow morning, 7:35 for pop choir. Also, an announcement for first block chemistry students. If you did not get your homework, you need to pick it up from Mrs. T. That's for first block chemistry students today.
Okay, we don't have logarithm on both sides, so we can't use our property that we learned at the beginning. Can we rewrite these as the same base? You should say no. So we are indeed going to use our property. We're just going to do log 8 to the negative x. So we're adding that log back into our problem. So from here, what we do is...
Jerica Tullis, please report to the office. Jerica Tullis.
What we do from here is we move that exponent in front. So negative x log 8 equals log 1.2. So what is log of 8 and what is log of 1.2? Well, if you type log of 8 into your calculator, you get 0.903. That's 3 decimal places. If I do log of 1.2,
Can we have a correction on the chemistry announcement? It's second block chemistry students. Please stop by and get your homework.
So, to solve for x, I can divide by negative 0.903 and divide by negative 0.903. So, I take 0.079 divided by negative 0.903 and I get negative 0.0876, and that is what x equals. Since we didn't have log at the beginning, we need to check to make sure our answer is right. But it doesn't matter if your exponent's negative, so it's okay. So see if you can do this one on your own based off of what we just did on the last one. So you should get log of 2 to the x plus 1 equals log of 5 to the 1 minus 2x. So we log both sides because we cannot rewrite 2 and 5 as the same base. Move your exponent in front. Figure out what log 2 is. You get 0.301. Distribute the 0.301, 0.301x plus 0.301. Over here, figure out what log of 5 is, and you get 0.699. So distribute and you get 0.699 minus 1.398x. So we have decimals, but we can work with it. We're going to move this, our x's to the left and our numbers to the right. So if I move this over here, 0.699 minus 0.301 is 0.398. And if I move my x to the other side, 1.398 plus 0.301, I get 1.699x. So if I divide 0.398 by 1.699, I get x equals 0.234. And there's your answer. Check it, see if it works. So try this one on your own. So you would do log 1.2 to the x, so I'm going to move x in front. You would do log of 0.5, so I'm going to move negative x to the front. So log of 1.2 is 0.079. Log of 0.5 is negative 0.301, so that's going to change that negative x to positive 0.301x. So if you add your x over here, you get, or you subtract your x, excuse me, I'll go this way so you don't get a negative. So 0.301 minus 0.079 is 0 equals 0.222x. Divide by 0.2222, and you get x equals 0. So, all right, see if you can do this one on your own as well. So we got x plus 3 log e. Oh wait, I'm going to use ln e. Why would I use ln? You should say because natural log's base is 1. Or e, excuse me. So ln of pi with an x in front. So ln 1 is just 1. You can type it in your calculator if you don't believe me. And then over here we got ln pi. And you get 1.145x. So if I subtract x, I get 3 equals 0.145x. If I divide 3 by 0.145, I get 20.690. And you're done. Alright, so let's go back to what we did at the beginning. Just a refresher. So here we got log on both sides. So when we had log on both sides, we had to rewrite it to have a single log on each side. So I'm going to rewrite this side as log base A of x minus 1 divided by x plus 6. I chose division because it was subtraction. This one I have log base A of x minus 2 over x plus 3. I chose division because it was subtraction. They both have log base A. So, like our beginning examples, those logs go away. And we can solve for x. So I would cross multiply. You're going to have to do area models to get your answer. You get x squared plus 2x minus 3 equals x squared plus 4x minus 12. Your x squareds end up canceling, yay. So you got 2x minus 3 equals 4x minus 12. Move your 12 over, you get 9. Move your 2x over, you get 2x. Divide, and you get 4.5. Plug in, 4.5 minus 1 is positive. 4.5 plus 6 is positive. 4.5 minus 2 is positive. 4.5 plus 3 is positive. So it's good. So this one only has a log on one side. 2 logs on one side. So we're going to rewrite it so it only has 1 log there. Division. When you had 1 log on a side, you had to rewrite it in exponential form. So I get 4 cubed equals x squared minus 9 over x plus 3. Anybody see a red flag here? You should see that this factors to this. So we could essentially cancel out our x plus 3's. So we have 64 equals x minus 3. Solve, and you get x equals 67. Plug it in, make sure they're positive, and you're good. And that is it. So, let's review, because this was kind of crazy. If there's a log on one side, you have to rewrite it as a single log, and then to exponential form, and then solve. If there is, you might have to pause the video because I do talk kind of fast. If there's log on both sides, you rewrite single on each side, get rid of your logs, and then solve. If there is no log, and you can't rewrite your bases the same, you log both sides, or natural log both sides, figure out some decimals, and go from there. So, please come with questions for this for next time.